welcome every panelist here. And I think now this is going into more of an interactive session where we'll be taking some of the Q&As and then we'll be discussing more. So the first question I think we have got for Mr. Vikram for you is like, how advanced are we in upgrading key components in smart energy solutions in India, right? And such smart grid, such as smart grids and smart substations, if we talk about in specifically.
When we look at the Indian utilities, we must understand that all are not at the same technology maturity level, all are not at the same governance level. So we have a wide spectrum of utilities and the tools and technologies that they have implemented. So we have some of the best technologies implemented in the world, which are functioning in I would say, global levels, best in class, whether it is in transmission or whether it is in distribution. We have some of the best utilities, some of the best performances of technology. There are utilities which have, you know, I would say, not taken 100% extraction out of the technology, but even some of them, I would say, have taken even 200% benefits out of the available technology that they had. But at the other end of the spectrum are utilities who do not have these tools, or who, if they have the tools, they do not have the wherewithal to make use of them, make use of the investment. And that is where a lot of work needs to be done.
Yeah, right. I think what you said is absolutely right. If we see the way the investments are happening, and also our grid is more complex than whatever we have seen in other parts of the world. Like we have got huge strength of network in terms of distribution. We are still heading into many of the innovations which we are already doing, and we a lot many investments also which are happening, which I feel like as part of RDSS. If I see like city level SCADA we need to implement on, all those things are already underway. So I think that would take it ahead only.
So when it comes to technologies, they are there. As Vikram also said, I think technologies such as, especially for the smart cities, whether it is gas insulated substation where it can take less space in the city instead of large space, because we know the value of space in the city. And also having the substations, the modular substation, prefabricated substation, and also mobile substation, which is required in cities. Sometimes you have suddenly the load growth there, and then you don't have space, and you have to set up the substation very fast to make the power available. So these technologies are already there. And I talked about the HVDC, which also is used now. Mumbai city is example where this technology also can be used to infeed the power to the city efficiently, and also without disturbing the land use, the right of way in the city. So this technology is there. And also technologies like asset performance management, how we can increase the life of the asset, and also ensure that the power available is 24/7. Because if you see today, we sometimes have load shedding, sometimes we have power interruption, but nobody actually calculates what's the loss of it's not just loss of power, loss of productivity and production and convenience for the people. So how do we monetize that? I think that's important now. Technologies are there. If somebody can actually do this economics, and then they can justify the usage of this technology, implementation of the technology.
What challenges still persist in terms of reliability, in terms of reliable power flow? If I see like for every discoms we have got reliability indices, we definitely track SAIDI and SAIFI and all those things. But what we still feel, what kind of challenges are still there, which discoms are lagging to actually improve their reliability indices or reliability of the power? So I can ask this question to Mr. Ankit. Will you be able to answer this?
Yes, sir. So see, despite all these advancements that we have done, especially the entire work which started with RAPDRP, then Saubhagyam and everything, and now in RDSS. I think the things that are holding us back are more of on the soft nature. I would say the lack of manpower and training. That is something which is a huge gap. And I feel, I can get you the best car in the world, but if you don't know how to drive it well, you can't really take out everything out of it. So as Vikramji also mentioned that there are some utilities who are doing really well, but at large, if you look at it, most of the people lack that manpower and training. That's one of the things I feel is lacking. Secondly, I think the government holding on to all the assets and asset management, these things I believe is something which sooner it is privatized, the better it might be. Is just my opinion based on what I've seen when working with private companies handling the assets and handling the lines versus the government. So I think these two would be really big factors, very soft factors, but I think they are pretty critical.
So like how we are going to have this Gen AI and AI tools to be implemented going forward for OT ecosystem? Because definitely in IT we can implement, but how they are going to leverage in OT?
Yeah, Anil, but before I answer that, I would like to answer also your first question, which you addressed to Ankit.
Yeah.
Yeah.
Thank you. Yeah, definitely. Thank you. Thank you.
Don't mind, but see, you have said that SciDi, SciFi, and all are recorded and they are. But if you get into the data says something else. There is no one way to calculate SciDi and SciFi by every discom or every utility. So there is absolutely that data of SciDi, SciFi, which is available in the public domain and which is made available also by the discoms in India, is not really reliable data because they don't have different methods of calculating. So let's be honest and let's be frank that unless we all agree that there is a problem and we try to work on solving that problem, we will whatever technology we use AI or Gen AI or tomorrow there is another version of AI, it will not be of use because we don't want to accept where we are. So let's first to say and accept that yes, there is a problem there, but we should all agree that how we go out of this problem. No?
Right.
So SciDi, SciFi is the starting point. If we don't even have that properly registered and calculated, then there is no way to show what is the improvement. So look, OT tools have over the various generations uh, been always been improved on the basis of the available IT generation at that point of time. The first SCADAs were built in 1950s, if I'm not wrong. Then thereafter, they were running on not 1960s, on the mainframe computers, which were bigger than probably one small flat in Bombay. Yeah. So since that time, we have moved on as the IT has moved using the newer latest technologies. And today you have got IoT based solutions which are available. Now, the next thing is on availability of Gen AI as tools to use this data. The one thing is, of course, to capture the data, and the second is to use the data and make sense out of the data and use it for decision making. So that is where, as the cost of sensors and the cost of communication comes down, you have more data which is captured and more data which is available in now you can call it a data lake or data pond or whatever is it. And then out of that data, you use the real critical information to take decisions. And that is where you cannot do without intelligence. You cannot do without AI. You cannot do without more advanced tool, and that is how we are looking at these IT tools as they are advancing and use them for managing our rapidly changing networks.
I think let's get back to the fundamental, the OT we call it. So when it comes to the electric power, as I said, electricity it's a sine wave of 20 millisecond. So every millisecond counts. So And when we have all these different applications, algorithms which are developed so far, they have been running since the inception of SCADA in 60s, 70s, and also later on the digital technologies. So there are very advanced level of advanced mathematical algorithms which are developed, which are tested maybe few thousand different cases, and then we say that yes, this algorithm, whether it's a protection or control algorithm, it will work. So then we deploy them in our SCADA or automation system or network control. So when we apply any technology to the power system in real time, it has to be tested, it has to be 100% reliable. On the other hand, you look at AI, ML, or Gen AI, they are not always 100%, they will never be, because they all depend on the sources of data, different sources of data, and also computation, cloud computation, and all. So you will not have 100% reliable operation from this. For example, a relay has to work, 100% right, and in 100% of the cases. Yeah. Whereas AI ML can always be, confidence level can be 60, 70%. That's why we have to have the right combination here. Yeah. Not just apply to the core system.
Agreed. I think so. I also have one opinion which I believe where we can put definitely AI, Gen AI or AI tools can be implemented in terms of for workforce management, for maybe for field service management, or for asset management, predictive maintenance, and also in terms of forecasting applications where we
Yes. Yeah.
definitely do a lot
Energy
many forecasts.
forecasting,
So we can also
forecasting,
yeah.
definitely.
Yeah, yeah, and one area which I feel is also can be implemented, which we feel like how we have to implement it, like for let's say for example alarm rationalization. We see in control centers we are flooded with lot many alarms in situations where we have got outages, kind of some storm or something. How we are going to leverage that to actually do the root cause analysis very fast. I mean, definitely right now we are doing with lot many techniques, but how these kind of technologies can be also evaluated. They can understand the pattern, they can correlate, and they can do lot many things on top of it. So this area also I try to see how it can be implemented in future, because right now I have not seen any use case yet.
No, I think Anil, you are right. I mean, we have used it in process industries, advanced alarm management. In a control room, the control operator will see some hundreds of alarm coming within maybe a few seconds or few minutes. So the operator, if he's very experienced, he can capture the right one. Otherwise, he may miss something very critical alarm. I think this using AI ML to really identify which are the, let's say, top 3 alarms which the operator has to immediately address in addition to the automated system what we have. Yeah, that's very much there, and that this AI ML system, it will be a learning system. It will go on learning and making it more and more accurate for the operator to take any decision. Yeah.
Yes, yes. Anil, this is a use case which has been implemented. Intelligent alarm processing module IAP has been developed, and it is in use also just for this particular purpose. When thousands of alarms are coming, where should the operator visually be diverted, and his attention should not be diverted to the wrong place. Yeah, that is IAP module has been there by Siemens. In many control centers, it was implemented. But the point is that any software or any AI tool will be as intelligent as the data that is coming into it. So if the data is not enough or data is wrong, then your results will also not be right. So it has to be that the basic foundation has to be very strong.
It's like in terms of where we see after 5 years, down the line, because right now if we see we have got AIML, I mean, a lot of things are happening around, right? And technologies are already in place. It is just the way how we are going to implement those, right?
No, it's
So
so I beg to differ here with this thing that the technology is in place. So it's very primitive where we are. It is, can we say it as an AI ML? No, of course not. We have, of course, there is an automation, planned automation system exists, but is it AI ML, real AI ML? No, the answer is no. That's my thing. The technology has to come, but for the technology has to come, there has to be a market. So if you see, the market is huge. Okay, the potential is huge. We all spoke about that. It is like predicting the market, the service, the software service market in the 1990s. Okay, the market is huge. Whether you talk about demand side management, and if you try to predict the market now, you can only go wrong. So whether it is in demand side management, whether it is with the generation side management, whether it is asset management, the potential is huge. AI ML can fit in everywhere, but as of now, the regulation has to change. As long as the regulation doesn't change, okay, you can't do much about demand side management. There is a regulation change. See, infrastructure can be built very fast. Okay, and the building blocks of infrastructure can come up very fast provided there is a market. So and if that doesn't happen, the pace of adoption will be very slow. What the way we used to the way we used to have electricity 10-15 years back, it's still the same. Okay, there is not much has changed, and I don't see it will change in next 5 years if the regulation doesn't change.